So here we're going to review everything we know about rational functions so far. So as you can see from the heading, this is the second page of your guided notes for this module. The first page was the turkey problem, right? So that would be a great place to capture this example. We're going to go through every feature that's going to show up in this delta math assignment. So we'll start with the newest one we know, and that is the horizontal asymptote. Okay, and remember, the horizontal asymptote deals with the ratio of our coefficients, right? So I find the biggest power of x here, it's the same, x squared. So I'll say there's a horizontal asymptote at 2 over negative 4, and that's a y value for a horizontal asymptote, and that reduces to negative 1/2. Okay, and notice we see that in the graph, that's that horizontal dotted line. So that's the first feature, that's the newest one. And the way we found that, right, is we took the ratio of the leading coefficients of the numerator and the denominator because they had equal degrees, right? Okay, let's move on now. Let's consider our vertical asymptotes. Okay, so to find our vertical asymptotes, we have to factor our function on the top and bottom because we want to make sure we find the factors left and the bottom that do not cancel out. So this is an interesting factoring case here, right? Because there's no c term, so we don't have to factor it like a quadratic. We just factor out a greatest common factor. So that's a 2 and an x on top, so I'm going to divide both terms by 2x. And what's left over when I divide 2x squared by 2x is x plus, and then 3 for that second term when I divide by 2x. And then the bottom, I'm going to factor out a negative 4x, and it's going to look really similar, right? So I'm going to have positive x minus 2 left over, and the way I can check that I've done it right is by distributing on the top, and if you think about it, I'm going to get what I had originally on the top and on the bottom, so that's how I know I've done it correctly. Okay, now I look for factors that cancel out, and notice I have an x and an x. X divided by x is 1, so what is left over is 2 over negative 4, x minus 2, x plus 3. Okay, and then my vertical asymptote, well, that's where my denominator is equal to 0, right? After I've factored out canceled out any terms that show up in both. So I'm going to take the 0 of the denominator, I'm going to set the denominator equal to 0. Divide both sides by negative 4, that does not change, 0, right? And I get x minus 2 equals 0, and then I get x equals positive 2 when I add that 2 on both sides. So that's my vertical asymptote. I'm going to write it that way, right? I'm going to write vertical asymptote at x equals 2 because it is that vertical line that I see. Okay, so the way I found that, and remember this is from Module 1, is I cancel out any common factors on the top and bottom. In this case, that was my x, right? And then I set the denominator equal to 0. So it's the zeros of whatever is left over. Okay, we might as well do our wholes now, right? So vertical asymptotes and wholes kind of go together. They're both where the zeros of the denominator. But in this case, I'm going to take that 0 that cancels out, right? So my whole is going to be at x equals 0. And notice I get that x equals 0 because that was my factor. If I had had like an x plus 3 that canceled out, for example, I'd set that equal to 0 and my whole would then be a number. But here I just get x equals 0. And then I need to plug that into my function to get the y value of the whole. Because remember, my wholes come with coordinates, right? So on my graph, that is this point. Notice that's a point at x equals 0. We need to figure out the y value. So I'm going to plug it in. I'm going to say, well, 2 times 0 plus 3, and then over negative 4 times 0 minus 2. And I get 6 on top, 2 times 3, and then a positive 8 on the bottom. I'll simplify that. That becomes 3 over 4. So my coordinate is 0, 3 over 4 for my whole. Okay. So there's my whole. The way I've done that, right, is I set my factors from the denominator that canceled out equal to 0. That's how I got this x equals 0. And then I plugged it back in to get the y. So that's my whole on my graph. We have two more things. And there are two things that you've always kind of studied with respect to functions. They are x-intercepts and y-intercepts. So my y-intercept is just going to be f of 0. So it's what I get when I plug in 0 for x. And I'm going to use this time the original function. Right, so I get 2 times 0 squared plus 6 times 0 over negative 4 times 0 squared plus 8 times 0. Okay, so that was from my original function f of x. Every time I had an x, I replaced it with a 0, right? And notice what I get. I get 2 times 0 plus 6 times 0 is 0 on top. 4 times 0 plus 8 times 0 is 0 on the bottom. I get 0 over 0. So in this case, my y-intercept does not exist. My graph never touches the y-axis. And that makes sense when I look at the graph, right? Because on the y-axis, I have a hole right there where it crosses. So it definitely never does touch that y-axis. It makes sense that there's no y-intercept. While we're up here looking at the graph, notice I have an x-intercept at negative 3. So let's figure out how we get that x-intercept. Well, the x-intercept is where the whole function is equal to 0. So I could set my function equal to 0. But think about how fractions work for a second. So 0 over anything is 0, right? So I actually don't need to worry about the numerator. I can just take, I don't need to worry about the denominator. I can just take that numerator and set it equal to 0. So I'm going to be like, well, 2x squared plus 6x equal to 0. And then I can solve by factoring again. And we already did this factoring. It looks like this. So I get x equals 0 from 2x, and then I get x equals negative 3 from x plus 3. And we're getting pretty good about that now. But remember, we canceled one of these out. So remember, we had a hole at x equals 0. And we saw that on the graph, right? So we don't need to worry about that x equals 0. Our x-intercept, our only x-intercept, is negative 3. So we need to, when we find these y-intercepts and x-intercepts, even though they're familiar things to you, we need to watch for ones that cancel out, right? So we had a y-intercept that does not exist, and one of our x-intercepts that we found was a hole. So our only x-intercept here is going to be negative 3.